And we're back. So sorry for everybody playing along at home. I did not get a chance to go over the homework in the video, so we're just going to start right into the lesson. Now, I just got done saying to these guys in class that we don't know anything other than an arithmetic sequence right now. So today what we're going to learn is a geometric sequence. Now, let me ask you this. Arithmetic was continually added, right? Geometric is going to be continually multiplying, which has some implications on, how fast or slow these things grow. Let me show you how. Yesterday we started off the lesson by talking about that example where you see the lightning flash, you count how many seconds, and that's the distance away as soon as you hear the thunder crash, right? So it was like 5 seconds was equal to 1 mile. This lesson starts off with this person bungee jumping. So we're here, and here's my tether. There we bungee jump and we go woo, and then you go down and back up again. Do you go all the way back up when you're bungee jumping? No, you go a little bit further, a little bit less, and then finally, you stop. You're kind of hanging there. You're like, okay, pull me back up. This is the height that they go back up to for each bounce. So the height for the first bounce going up to 200 feet, and then the second one going up to only 80 feet, the third one going only up to 32 feet. First, let me ask you this. Is this an arithmetic sequence in the y value? Is this arithmetic? No, because my first term goes from 200 all the way down to 80. I'm going down 120. Do I go down another 120 to get my next value? No. But what do I go down to? I go down to 32. So when there's not a subtraction, so maybe there's some sort of multiplication going on. Maybe there's some sort of decrease by a ratio rather than a subtraction. Well, if I want to know what I'm multiplying by, the easiest way to figure that out is by taking a simple equation where I say, okay, 200 times something is going to get us to 80. How do I solve for that question mark? How do I solve for that question mark? I divide over to the other side. So this question mark is really going to be 80 divided by 200, which is 0.4. So I can remove the question mark and say, okay, now I know what this thing is. Now I know that I'm multiplying by 0.4. What I have to check to see is that, does that pattern continue? Does this pattern continue? Let's check it. If I take 80 and I multiply it by 0.4, does that get me 32? Yes. So a pattern where you are continually multiplying is what's called a geometric sequence. That's our formal definition. The height of the bounce is shown in the table above, forming what's called a geometric sequence. A geometric sequence is the ratio of successive terms is the same number. Sometimes called the common ratio, sometimes called the common factor, sometimes called the common multiple, whatever you want to call it. It's the thing that I continually multiply by. Sometimes usually it's used with the letter R for ratio, okay? Usually we use the letter R for ratio. All right, so let's take a look at an example. I shouldn't have needed to say that this was geometric. You should be able to figure that out. Is this geometric? Obviously, yes, because the directions tell me. But how do you know for sure based on the numbers? Times 4. Do you see the times 4 pattern? Do you see 1 times 4, times 4, times 4? Okay, well, let's keep it going. Let's find the next 3 terms. 64 times 4, times 4, times 4. So my next 3 terms are 256, 1024, and 4096. Yeah, 4096. Now, hold on. Everybody watch along at home. My board went out. Maybe I'll try to close and reopen. There we go. Okay. What's the numbers on there? There's 4. There we go. Good. Now, let me say this. We started with 1, and only by the 8th term, we're already up over 4,000. So it grew pretty quickly. It grew very large, very fast, didn't it? Yeah. Okay, this grew very large, very fast. What we're going to find in the rest of chapter 11 is this kind of special name is called exponential growth. Exponential growth, meaning it's going to grow fast, quickly. It's going to go large, very quickly. Going fast, quickly, that's like saying the same thing. It's going to go large, quickly. Right? That's exponential growth. Just by the 8th term, I'm already up over 4,000. And the reason is because it's always continually multiplying. Repeated multiplication. Okay, let's take a look at one with a fraction, because that's when it's weird. That's when it's messy. All right, let's take a look here. First thing that I want to look at is that the fact that it's going from negative to positive, to negative to positive, to negative. What's that telling me about the number that I'm multiplying by? That the R value is going to be negative. Because if I multiply by a negative number, it switches the sign. And then I multiply by a negative number, it switches the sign. And I multiply by a negative number, and it switches the sign. So I know my R value is going to be negative. Let's figure out what it is. Now, this is the first time where I'm taking the value and I'm decreasing the value. See, when we were talking about an arithmetic sequence, we might have said that this was in a subtraction then. So we may try to say division, but I would strongly caution you against that. Because I want to look at this as multiplication, because that's what's going to go in my equation a little bit later on. So what am I going to multiply 9 by to get to 3? What am I going to multiply 9 by to get it down to 3? What am I going to multiply 9 by to get it down to 3? Wouldn't be negative 3. Well, if we don't know, let's think about it. Negative 9 times something is 3. Well, we divide over to the other side. This would be negative 3/9, or negative 1/3. And that's my common ratio. Don't say divided by 3. I know that's what you see, but don't say divided by 3, because that's not what's going to be your R value. The R value is going to be 1/3. The common ratio is going to be negative 1/3. Negative 1/3. Negative 1/3. Negative 1/3. So let's keep that going. The next term should be positive. 1/9 times 1/3 is positive 1/27. I just multiply the bottoms together. 3 times 9 is 27. I multiply this by 1/3 again. Multiply the bottom by 3. That's 1/81. And since it's a negative, since my R value is negative, I have to flip the sign. And then it flips back to be 1 over 243, positive. That's a really small number, right? So we got really small really quick. That's not exponential growth. That's what's called exponential decay. We have these two sides, exponential growth and exponential decay, something that shows up a ton on the end of course test. You will see those terms a lot. Exponential growth, exponential decay. Exponential decay is when things keep getting smaller. Exponential growth is when things keep getting bigger. You know what the difference between the R values were? The R value was bigger than 1 in my first example, and in this one, less than 1. That's a key indicator of the exponential growth versus exponential decay. Let's take a look at this one. Do you see how the signs alternate again? That tells me that my R value is negative. And what am I continually multiplying by? 2. So it's negative 2. I'm continually multiplying by negative 2. So my R value is negative 2. And let's keep going. My next term, so we were at negative 40. We multiplied by negative 2 times negative 2 times negative 2. So we were at 80, negative 160, positive 320. Notice how my signs are alternating again. And now let's look at our last one. Am I increasing or decreasing? Decreasing. What's that tell you about my R value? No. Don't. The R value being positive or negative has no bearing on the actual values of the number. The only thing that that's going to do is make the sign alternate. That was the arithmetic sequence. Decreasing to increasing in terms of the sign. What is this? What is the fact that it's decreasing tell me about my R value? What's that? It's a number less than 1. It's a fraction. Or a decimal. Right? It's a number less than 1. Because I'm going to be multiplying by a number smaller than 1, so it's going to keep getting smaller and smaller. Like think about multiplying by a half. Right? It's going to keep getting smaller and smaller each time we take it. So let's see, what number is this? I don't know. I don't know how to get from 512 to 384. Well, the best thing to do is to say, well, that's a question mark then. 512 times something is 384. And then solve for that value. 384, divide over the 512, 0.75. So that's my common ratio, 0.75. 0.75. So let's keep it going. I've got 288. I'm going to multiply by 0.75, multiply by 0.75, and multiply by 0.75. So that's going to get me 216, 162, and 121 and a half. Oops, not 125 and a half, 121 and a half. Questions about that? Now, what if I had said to you, okay, find the 100th term? Would it make sense to like actually keep multiplying? I mean, that's not logical. There's got to be a better way around it. There's got to be some sort of equation. Now, we introduced this A sub notation yesterday. Yeah. We introduced this A sub notation yesterday. So I'm not going to go through that again. So I want to show you what the formula would be. Here it is down here. Circle it, star it, box it, do whatever you need to do. I'm going to add it to my running tally of formulas here. A sub n, what does A sub n mean? That's the term you're looking for. N goes in for the term that you need to find. So if you're looking for the fourth term, it's A sub 4 is equal to. And then it's A sub 1. What is A sub 1? The first term. And now instead of adding, what we're going to do is multiply by R, our common ratio, to the n minus 1. That's where the n minus 1 goes. It goes up in the exponent. So you have your starting value not added anymore, but multiplied, because that's the pattern with geometric. A sub 1 times my ratio, but I've got to multiply it by that many times and take it to the power of n minus 1, where n is the number of term that you're looking for. You still do the n minus 1 thing, but instead of multiplying by that value, you're going to raise that r value to that power. So let's take a look here. The first term of a geometric sequence is 500, and the common ratio is 0.2. What is the seventh term of the sequence? All right, so let's take a look. My first term, my A sub 1, I'll write it out in my formula. A sub 1 times r to the n minus 1. A sub 1 is 500. R is 0.2. And the number that we're looking for is seventh term. So let's plug it in. 500, my starting value, times 0.2 raised to the 6th power. 500 times 0.2 to the 6th power. So we run that number through our calculator. 500 times 0.2 to the 6th. And now I don't need to do more repeated multiplication. It's just 0.032. Which is kind of interesting. Starting at 500, in only 7 terms, I'm down to a number that's 0.032, a really small number. So it gets really small really quick. That's the 7th term. Don't believe me? Try it out. We got 500 times 0.2 times 0.2. Gotta let it catch up. Oh, one more time. There it is. I did that 7 times. Okay. All right, let's take a look at another one. For a geometric sequence, a sub 1 is 5, and r is 2. That means my starting value is 5, and I'm continually doubling. 5, 25, 50, 100, 200, and so on. I want to know what the 6th term in this sequence is. Well, we got 5 times r to the n minus 1. What goes in with my exponent? 5. 6 minus 1. 5. Okay. 5 times 2 to the 5th. 160. I must have done something wrong there. But it's 160. 5, 10, 20, 40, 80. Okay. Again, like I showed you on the homework, this is the type of question that the air test is going to give you. Everybody look how I changed the directions. Everybody look up at the board. Look how I changed the directions. This is the type of question that they're going to give you. They're going to say, what's the 9th term of that sequence? Do you know whether it's arithmetic or geometric? Can you tell? Yes. And then you have to tell what it is, and then use the correct formula to do so. All right. How do I know that this is geometric? Not necessarily. That's why. You're right that the numbers aren't going to get bigger. I see positives and negatives. That's true. What am I continually multiplying by? Do you see a continual multiplication? Yeah, -3. That's how you know. So I'm going to multiply by -3. -3. That's a times. -3, right? That's my r value. So I say a sub 1 times r to the what power? To the 8th power, n minus 1. So we go into our calculator, we say 2, don't forget to use parentheses, raised to the 8th power. Wow, over 13,000. So I started with 2, and only in the 9th term, I'm all the way up over 13,000. Something that grows really, really fast. Gets big really fast. Yeah. Take a look at another one. Look, I did change the directions before this. What is the 8th term of this sequence? 8th term of this sequence. Well, the 8th term of this sequence, I know that it's geometric. How do I know that it's geometric? Because multiplying by 1/2. And do you see how it's decreasing? That means I'm multiplying by a number that's smaller than 1. I'm multiplying by 0.5, right? So I know that I take my first term times 0.5, or 1/2, raised to the what power? 7, and minus 1. Okay, we take 1,000 times 0.5 to the 7th. 7.81. Questions about that? Okay. I reminded you about the parentheses. Don't forget about parentheses. Let's do a word problem here. Because I'll tell you what, more often than not in nature, in the world, in real life problems, things happen geometrically. Things happen with a constant ratio. Like, we'll talk about a little bit later on, exponential growth. Like, in the beginning of the pandemic, things were growing exponentially. Like, each day, there was it kept getting bigger and bigger and bigger. I don't know if you guys have paid attention, but one of the key numbers that they talk about all the time is called the R value. You know what that is? It's the thing that we're continually multiplying by. It's this exact number that we're talking about right here. So that happens a lot in the real world. Exponential growth happens, and exponential decay happens a lot in the real world. One of the real life examples that we'll talk about a little bit later is half-life. Have you guys studied half-life in science classes? It's like naturally decaying things. We'll talk about that a little bit later on. I wasn't sure if you guys talk about it. All right, so this again, this is like a bouncy ball dropped from a certain height. Does it always go back up to the original height? No, it decreases in height. Based on the consistency of the ball, I want my bounce bigger or smaller. What am I continually multiplying by? Again, by 0.5. Oh, by 0.5. So that means my starting value, 300 times 0.5 raised to the what power? Fifth power. N minus 1. 6 minus 1 is fifth power. I'm looking for on the sixth bounce. So 300 by starting height times 0.5 raised to the fifth power. 9.4. 9.4 centimeters. Okay? Yeah. I mean, if this was in the end of course test, it would probably tell you what to round to. But honestly, 10 hundredths is fine. Round. What's that?
Did you get that in the calculator?
No, I rounded. I rounded. Yeah, I rounded it to 9.4. Shh. Turn around. Turn around. All right, let's take a look at this last one here. This is a real life example. The table shows a car value for 3 years after its purchase. So you guys know that as soon as you purchase a car, as soon as you drive it off the lot, it decreases in value by law. As soon as you drive it off the lot, it decreases in value. And you know what it does? It exponentially decreases. The longer you have the car, the smaller and smaller the value is going to be. So let's figure out what it's going to be in 8 years. I bought an $18,000 car. Let's see what it's going to be in 8 years. Now, are you able to tell what the thing I'm multiplying by is very easily? No. What do you know about that number, though? Right, it's going down, so what's the R value going to be? Fraction of decimal. So let's figure out what it's going to be. I know 18,000 times something is going to be 15,300. So let's just divide over that 18,000 over to the other side. .85. So I know it's 85%. Look, I'll just turn that into that. Oops, 0.85. It's 85% of the value from the year before. That's what we're really saying here. So let's see. I started with 18,000. Multiplied by 0.85 raised to the 7th power. So 18,000 times 0.85 raised to the 7th power. $5,770.39. So in 8 years, that $18,000 car decreases all the way down to a little under $6,000. It's almost a third of its value in 8 years. All right, let me turn off the video. So long, everybody watching along at home.